As you can see on your screen, this is an informational webinar in the upcoming program at MIT xPRO. The program is entitled Robotics Essentials, Designing and Building Robotic Systems. So we certainly have a lot in store here today. We're going to cover two key areas. If you've been on a session before, you know this already. We're going to be covering what we're going to be learning in this program, as well as how that learning is delivered. So we're going to be making our way through the curriculum and gaining that deep understanding of those learning objectives. We're also going to be learning about that tactical component of being a participant in the program. What does it look like? What does it feel like? So a lot in store here for you as we share this next hour together. But you all are the star of the show here today as you invest in your learning and you invest in your education. With that, I am going to now introduce our other stars of the show, our program faculty. We have with us here Julie Shaw. She's a professor in the MIT Department of Aeronautics and Astronautics. She is also she leads the Interactive Robotics Group at the MIT Computer Science and Artificial Intelligence Laboratory. Professor Shaw, would you like to jump in and greet our audience here today?
Hello, it's so great to meet you all. Thank you so much for joining from around the world. It's a real pleasure to be a part of this class, to have put it together, and we look forward to you engaging with us and with the course content.
Thanks so much, Professor Shaw, for being here. We very much look forward to hearing more from you here in just a moment. We're also joined by Professor Alberto Rodriguez, who's an associate professor of mechanical engineering at MIT, class of 1957 as a career development professor. So Professor Rodriguez, would you like to jump in and greet the audience as well here today?
Yeah, absolutely. It's great to be here. Thank you very much, everyone, for joining. We're super excited to kickstart this program. So yeah, looking forward to your questions today.
Thank you, Professor Rodriguez, as well, for being here. It's going to be such an honor to learn from you both. I'm going to be handing over the spotlight to our professors here in just a moment, but we wanted to give you a little bit more detail about their bios, their backgrounds. I'm not going to read these slides word for word, but we are recording today's session, and we invite you to come back and take a look. We're going to provide you with copies of the recording from today, as well as the slides. So open up those slides when you receive them in your email and take a look at some of the content here on the bio slides for your program faculty. But certainly both of our program faculty here bring a wealth of knowledge and expertise to this program. You can see Julie, in addition to her role as professor, her work aims to imagine the future of work by designing collaborative robot teammates that enhance human capability. So I love that tagline here. You've expanded the use of human cognitive models for our artificial intelligence. You've translated your work to manufacturing assembly lines, healthcare applications, transportation, and defense. So certainly a wealth of knowledge here and experience brought by Professor Shaw. Professor Rodriguez here is, in addition to being an associate professor of mechanical engineering, he leads the Manipulation and Mechanisms Lab at MIT, which researches autonomous dexterous manipulation, robot automation, and end effector design. So that is quite a lot there that you bring as well to the table. There's more here about awards and other areas and publications here. You're the recipient of the 2020 Early Academic Career Award in Robotics. So certainly a lot here in store for you as you think about the world-renowned expertise of these industry leaders and what they bring to this program. I warmly invite into the spotlight our program faculty. Julie, I'm going to hand it over to you to take us away with the program overview. Thank you again for being here. Over to you, Professor Shaw.
Thank you so much. So we're delighted to tell you more, about this course. Oh, wonderful. Thank you so much. So our aims in this course are to be able to introduce you to really the fundamentals of robotics and automation. We aim to do that by introducing you to a wide range of robotic systems, robotics applications, but to do more than that, to be able to provide a framework for understanding the different elements of a robotic system, what we call a sort of a full stack of a robotic system. And the components of it, how those components interrelate, where this course is meant to provide this broad view, but also this beginning of a deeper view of each of the elements of a system, and to be able to provide a deeper appreciation for the current opportunities and limitations of use of robotics, so that you can be sort of savvy engineers and customers of technology, and be able to move forward and better utilize existing technologies and advance the state of the art in your learning or in your work. And so this involves working through sort of the key concepts of robotic systems. Equally important as the robotic system itself is the interface to that robot and the environment, and very importantly, the interface between the robot and the human. There's always a human involved in designing and programming, in deploying and supervising the system. We'll learn about how robotic and automated solutions are designed to be suitable for different tasks, and ways in which it can be challenging to deploy existing technologies for some tasks that, for example, may be very natural for a human to perform. We'll identify the basic robotic subsystems, and talk at length and discuss and through interactive experiences, work through how these subsystems influence and interrelate, how the design requirements of one affect another subsystem, and how the design of this whole system as a system of systems is a really exciting and compelling field to be able to gain proficiency in. We'll talk about how automated technologies are implemented and used in practice, and the barriers that exist in utilizing these technologies today. The different robotic systems have subsystems, but they can be composed in different architectures, and we have choices in designing the architecture of a robotic system as well. And then finally, we'll discuss the basics of each of the components of robotic systems, for example, sensing and control, and discuss the state of the art of each of those disciplines and systems that make up the whole. So on to you, Alberto.
Excellent. Thank you, Julie. So as Julie said, the course is designed based on this full stack robotics perspective, right? So the idea is we would like you to understand robotics in the context of a system, which is key in general, but even more when we're trying to develop robotics for automation in the course. But in a nutshell, the course will expose you and will mean to build an understanding of the different layers that compose a robotic system, all the way from motion control, different ways in which architectures that we have to be able to generate motion commands to generate behavior in a robotic system, programming languages that are used to specify those behaviors, computational models that are used for behavior generation or for perception, as well as the intricate sort of relationships between human and robot interactions when the human becomes part of the automation system, or as Julie says, always, because the human is always in some way part of that automation system. I'll pass it on to you, Julie.
Thanks. So in terms of how the course is architected, we're aiming to be able to provide you foundational knowledge that you can build on regarding the development and design and deployment of these sort of full stack robotic systems. Our goals here are to work together to build your foundations, again, to be able to understand and identify sort of the key concepts that underlie modern robotic systems and human-robot interaction, to be able to go a little bit deeper and investigate the particular subsystems, for example, the control systems, the sensors, the specification of these subsystems, the algorithms that we use in many many modern day techniques. And then how we compose them together to build robotic systems and our choice and selection of architecture. So we aim to build the foundation, build your confidence to be able to explore and investigate various robotic systems, their capabilities, understand their use, and and be able to work through the strategies that we use for sort of safe and responsible deployment of these systems today. And especially for those of you that have jobs that can benefit from this course material, we're looking to be able to have you be, conversant and build expertise in these systems. And to that effect, there's a broad range of additional activities and engagement, including the development throughout the course of a course workbook that you use to be able to reflect on the course material, map out next steps, in each stage of robotic design and implementation. And of course, a very important part of this course is learning and growing together through the really outstanding peer network from, as you can see, around the world.
Okay, so let's go to look a little bit more in detail into the content of each one of the 10 weeks of the course. The first week is really just an orientation for you to familiarize with the platform that we're using for the course. Everything will be, you will access everything through a Canvas interface, and there's benefit in you spending a little bit of time in the platform to familiarize yourself with the different types of activities, as well as an opportunity for you to get to start knowing the peers that are taking the course, which will be the people that you will interact with during the following weeks. And in week 2, we really start the course, the content of the course, with trying to, before going into the details of robotic systems, trying to understand the context of where these robotic systems and automated robotic systems are happening. We will talk and categorize different important aspects that are necessary to understand in the context of industry as well as society, to be able to understand sort of the barriers and the opportunities for the adoption of robotic automation. Robotics and automated systems, they don't happen in the vacuum, and being able to identify what makes an opportunity and what makes for a barrier for automation, it's a key part of the process.
Great. And then in week 3, we'll begin discussing the different elements of a robotic system. I think my personal view is that one of the most exciting aspects of robotics is that it is this systems discipline. And it's composed of these various subsystems, but more than that, the interesting thing about a systems discipline is that you can aim to individually optimize each element of your system. For example, sensing, task planning, motion planning, trajectory planning, control, the sort of embedded systems components, even the human interface. If you aim to optimize each of those systems individually without consideration of their interconnection and influence on other elements of the system, you're pretty much guaranteed in the end to end up with a suboptimal overall robotic system. So we begin by discussing each of those subsystems, but also giving you a sense of the importance of designing for and considering the interaction among all those systems right from the beginning. And from there, we move into deeper dives into each of those subsystems.
And the first one of those deeper dives in the 4th week of the course is sensing and perception. And we will describe sort of the algorithmic process that involves sensing the environment and sensing the state of a robotic system, all the way to making decisions for how the robot should behave, as a hierarchical structure that gradually captures raw information, which becomes more high-level information or more abstract information about the state of the environment or the robotic system or the task that robotic system is trying to achieve. and paired with a similar hierarchical architecture that sort of gradually turns those observations into more detailed decisions as to what should be the command sent to the actuators of a robotic system. And in week 4, we will look to the perception part of that pipeline, and we will delve into different types of perception algorithms as well as sensors themselves. So we will discuss the perception pipeline in general, as well as we will do deep dives into specific algorithms as well as specific sensors, both in vision as well as in force or tactile sensing.
And so on to week 5, we'll discuss robot decision making. So you can think about your robot needs to decide what it's going to do and how it's going to do it. And obviously those decisions are interconnected. So, how a robot can move is going to affect what it can do. Week 5 focuses on task planning. I see a question in the chat. Will basic AI be incorporated into this course? And the answer to that is yes, in multiple of these modules. One place that this shows up is in robot decision making and in robot task planning. And we'll look at the various models and approaches that we use. First of all, how do we define a task planning problem for a robot? The steps that a robot should take, the constraints it has to adhere to as it decides in what sequence it takes certain actions. Related to sensing, what can the robot sense about the world? What might not be directly sensible, or what might be kind of partially observable, has implications for what models and what algorithms we use for robot task planning and this higher level decision-making module. And we'll also talk about, as I mentioned, the connectivity to the next set of questions. So you might determine sort of sequence of steps for a robot, but how does that need to be influenced, or how does that need to be informed by the physical capabilities of the robot, the motions, the configuration of the environment. But there are many elements of sort of classical AI and sort of modern AI incorporated into this class, and task planning is one of those subfields of AI.
So you can think of week 5, 6, and 7 as sort of these sort of hierarchical process to decide what the robot should do, starting in week 5 from the highest level. From the highest levels of cognition, task planning, AI, sort of task-oriented decision making. And going into week 6, where we will focus on motion planning and trajectory generation, thinking of, okay, we want the robot to perform a certain task through a sequence of sub-goals. How do we get the robot to do that in the context of what are the trajectories that the robot should follow to be able to achieve that? So in week 6, we will look at different types of algorithms to generate trajectories and motion plans, including optimization-based trajectory generation, as well as sampling-based trajectory generation. And then in week 7, establishing control, we will go one level lower, even in that hierarchical pipeline, once we have an understanding of what are the trajectories or sequence of fine-grained sequence of states that we want our robot to, or a robotic system to go through. How do we actually talk to the actuators in that system? How do we get the control loops in the actuators to actually get the robot to do what it has decided that it wants to do? So we will look at different control architectures, all the way from the simplest possible architectures, PID loops, to more advanced architectures like model predictive control, depending of the complexity of the system, and trying to build an understanding of what type of robotic system is a good match for which kind of control algorithm.
Great. And then week 8 is where we have a discussion about how all these processes happen sequentially, concurrently. How do we actually make them happen concurrently? You can imagine that a robot that senses, plans, and acts in sequence might be less ideal because it's sort of laggy, it senses and then it's done sensing, but while it's acting, what if something about the environment changes? You'd like it to be responsive to that. At execution, something, might not go exactly as planned, and you want to be able to close the loop while also integrating sensing of your environment. And so I like to call week 8, how a robot walks and chews gum at the same time, how you ensure that all of these processes are interleaved according to the constraints. Imagine a walking robot. There's clearly sort of a time constant. There's time constraints under which certain processes need to be executed, or new sensing needs to be incorporated into the system. And so we'll talk about the considerations of how we, at the lowest level, including down to the hardware and the embedded system, ensure that we are able to execute these various processes according to real-time constraints and deadlines, and as well as considerations on networking of concurrent systems. Great. And then week 9, we'll talk about human-robot interaction, which is a theme that is embedded into many of the modules up until this point. As Alberto and I have said, there's a human sort of involved and embedded in every robot system, even a system you intend to operate independently from a person. Never truly operates entirely independently from people. And so thereby design of that human interface and consideration of the models and the algorithms that you're employed and how they make things easier and harder for the various roles that a person needs to play in deploying and operating that robot system becomes very important. So we'll talk about the various architectures and methods we can use at each step. So conceiving, designing, implementing, operating, for example, in teaching by demonstration or programming by demonstration, as well as other interface considerations. So the interfaces that you would use, for example, to control a bomb disposal robot may be different than a robot in a factory or another setting.
And finally, in week 10, we will circle back to trying to understand now, with our sort of renewed or improved understanding of robotic systems, how do we look at the future of robotics, especially in the context of societal needs as well as industrial needs. We will try to highlight sort of current technologies that are sort of thought to revolutionize robotics in the near future. Many things that we have not been able to, that the course itself cannot cover because of the sheer size of the field, but also trying to get an understanding of how do we think about the revolutions that we still cannot see. How do we try to understand what are the drivers of new technologies and new revolutions in robotic automation?
And in terms of how we'll go about doing this through the course, an integral part of the course are the assignments and projects, which have been carefully designed to support you in sort of building your intuition, which is based on the foundations and the concepts and deeper knowledge of each of the components of robotic systems. And so you'll have the opportunity to explore the various robotics capabilities and subsystems through interactive scenarios, interactive activities. Interaction in this course, even among the people, is very important. So there's a really exciting set of crowdsourcing elements where you'll be able to share and learn from one another about your understanding or experiences in developing and deploying real-world robotics applications. As we mentioned, there's a course workbook that each of you will work through, so module by module. And this is an opportunity for you to take the elements of the course and make them relevant to your own experiences and your own interests, to be able to record your reflections based on each lesson. And then make your own plans as to how you integrate and synthesize this information into conceiving, designing, considering deploying a full stack robotics system that may be relevant to you or your organization. And also really fun, carefully designed try it activities to be able to not just listen to content from Alberto and I, but to take those concepts and really try it out, be able to test your understanding, kind of get feedback interactively right in that moment, and be able to hone your understanding of the material step by step throughout the course. And so with that, I think I can turn it back over to Marie.
Yes, thank you so much, Professor Shaw, Professor Rodriguez, for being here and taking us through these. I see many of you have been putting questions there in the box. We have one question that's been answered. So our man asked, if I'm stuck or have a roadblock, how can I get help? So I see that one of our program support members have already answered that question, but I'm going to broaden that question out here because it's a great segue into the next section here where we're talking about the learning experience. What is that day-to-day experience like? Where do you go for help? How can you get the support that you need in the program? But with that, let's go ahead and dive into the learning experience here. Firstly, as you think about this broader community that you're joining here, we invite you to learn a little bit more about MIT xPRO, its mission here, and its dedication to online learning. As you can see, MIT xPRO is breaking down barriers of access to the incredible wealth of knowledge housed within MIT faculty to make learning accessible anytime, anywhere to all of you. Not only is the learning designed around cutting edge cutting edge research, as you saw here today, as you learned from our professors. But the content is designed around what we know works well for adult learners. So we're thinking about the neuroscience of adult development, the neuroscience of learning, and how best to design these programs that convey that knowledge to you in a way that's retainable, accessible, and that's going to help you to bring to life these concepts in your professional roles. So that's what MIT xPRO is designing programs around. They're application focused, really helping you to build skills on the job and bring to life these concepts and theories into a place of action. So a lot in store here in the program. If you'd like to explore other programs at MIT xPRO, you can see here on your screen, there's a link to the full portfolio. But certainly this program here, Robotics Essentials, is a very relevant topic here. This is a 10-week program. We're estimating 4 to 6 hours per week. So as you think about those logistics and planning around your schedule, we've put together a program here that is a blend of synchronous and asynchronous learning that allows you across these 10 weeks to really design a schedule that works for you. So there are live components we'll talk about in a moment, but a lot of the activities and exercises are happening in an asynchronous fashion with your cohort, allowing you to really build out a schedule that works around your other responsibilities. But you can see here on your screen, it's certainly a relevant topic to be exploring here. Organizations need talent with the right combination of skills to bridge some of the technical aspects of robotics and the strategic imperative for business cases. So certainly as you think about this program, the global robotics market is set to reach $74 billion by 2025. So this is a growing market and certainly a good place for you to be exploring as you seek to learn more about Robotics Essentials. So here is the kind of overview here of this program. It's going to be an immersive curriculum. You're going to be rolling up your sleeves and diving into the material, interacting with it, tinkering with these ideas, bringing them to life in order to strengthen your understanding of real-world robotic systems, evaluate human-robotic interaction, and analyze the very real challenges of implementing robotic systems in society. This program was designed for a broad range of folks here, but you can see anybody who really wants to launch forward in a path in full stack robotics. So you might be an engineer, a product manager, a consultant, or another professional in a related industry looking to springboard into some career advancement roles with the knowledge of robotics. So a big part of this program is designed around career preparation. We know many of you are looking to formalize your training to launch into career advancement opportunities. And so you can see we've built into the program exercises as well as other areas for you to get that career prep help that you need. So when you advance from this program, you'll be prepared for a variety of different job titles. Those are listed there for you on the right of your screen if you're interested in taking a quick peek at some of the job market opportunities that this program will help you to achieve here. So we see a growth rate of 40% in the robotics engineer ranks, second among LinkedIn's top 15 emerging jobs in the US. So certainly, again, if you're here for career preparation, this program is designed for you, and it's designed to help you to launch into a career in this fast moving market. Some of what you can expect here in the program, we heard some of this from our professors, certainly those action assignments that are those try it activities and those case studies, really business use cases that you'll be looking at, and some of those tools that were covered here as well. You can also expect from the program, you'll be getting those career-ready skills to position you in a growing market. So we have course leaders at the helm of your career preparation, helping you to get prepared for job interviews and advance forward in a job market. You'll gain a workbook from this program. This is a tangible takeaway that helps you to apply your learning. So these methodologies and frameworks that you're learning throughout the program are going to be culminated in this tangible workbook that you can then take with you and use again and again. Another tangible takeaway here is the certificate of completion that you have an opportunity to earn here in this program. And certainly, again, if you're looking to springboard into those career advancement opportunities, having a certification, a credential here from MIT xPRO is going to go a long way in helping you to achieve those goals. So a lot to look forward to for those of you looking to formalize your training and advance your careers here. So this is a chance to earn that credential. In addition to the learning, in addition to this certificate, of course, the other big advantage in this program is building a network, a professional network of colleagues. This is a cohort-based program, meaning that you're coming in together with a cohort and you're learning shoulder to shoulder with a global team of peers. So as you see these concepts come to life in your work with your ideas and your organization and industry, you're also going to get that broadened scope of understanding as you see these themes come to life for your peers and colleagues as well. So a lot to look forward to as you think about the relationships that you'll build in this program, the relationships with your faculty, as well as your peers and course leaders. This is certainly a program with a lot of support. So hopefully that answered your question there. Armand, about, where do I go for support? Certainly many different layers here. If you're a visual person like me, I think of it as sort of concentric circles. You have yourself at the center, your peers who you're learning with and from. You have your course leaders at the helm of your day-to-day learning, helping with those career advancement opportunities, giving you individualized feedback on your assignments, and helping to answer your questions throughout the program. A layer beyond that, you have your program faculty, Professors Rodriguez and Shaw, here with us today at the helm of your curriculum. And then, of course, beyond that, that broader community here at MIT xPRO, really setting the stage and setting the context for the learning in the program. So many different layers of teaching and learning and relationship building, all of this housed together by our 24/7 program support team. And certainly Armand and others who have asked questions there in the Q&A have already been met with our program support team. They're here with us live on the call today. We have a team of program academic advisors helping to support the session here and answer questions there in the Q&A box. So we have with us here Jaydeep, Vrushal, Priya, and Raja, all here with us helping to answer questions. These are our program academic advisors, our 24/7 program support team. And they're here to help with any of those logistical questions that you have about the program, any questions related to the registration and enrollment process, any questions related to course policy. Our program advisors are the experts. They're the closest to those details. They're here with us live on the call, answering questions in the chat that are related to those logistical details, course policy, and the registration and enrollment process. So we invite you to get connected one-on-one with one of our program advisors. If you haven't done so already, you can click on the link in the chat, and it's going to take you right over to the course enrollment page, which looks very similar to what you see here on your screen. That course enrollment page, if you click on the Apply Now button there, it'll invite you to put in your contact details and schedule a one-on-one appointment with one of our program academic advisors. So as I mentioned, our advisors are here. They are the experts in all of the logistics for this program, all of the course policy details. How do I earn that certificate of completion? What's the evaluative criteria for the program? And then any of those registration questions you have. And certainly if you're interested in exploring exploring discounts, special group enrollment pricing, or other flexible and transparent payment options, our program advisors can help walk you through those details as well. That's listed for you in your chat as well. That's MIT@emeritus.org. So certainly you can send us an email there at MIT@emeritus.org, and we'll get you connected with an advisor that way as well. But with that, let's go ahead and open up for our live faculty question session so we can begin making our way through our questions. So Professors Rodriguez and Shaw, which language will be used? Arduino or Raspberry Pi, C, or Python? Can you talk a little bit about the programming language and maybe some of the rationale behind the language of choice here for this program?
To get started. So the course is designed both for someone who does not have prior, experience or some very significant experience in programming, as well as to be valuable for someone who does. And you're not required to program as a part of this course. And so the course is aimed at building the foundations, the basics, your understanding of robotic systems in a conceptual manner, which is, for anyone who does program, what is the old adage? Like the longer you delay starting programming, the sooner you'll be finished. That's definitely the same for robotics. So understanding the architecture, understanding the specifications, and the capability of each of those components, their interrelationships, and being able to practice and hone that understanding in a way that's removed from code can be very, very valuable for those at many experience levels. So if you're coming into this course without prior experience programming, that is great, and you'll gain a lot from this course. Maybe the point to add is that those that are building robotic systems will come away from this course with aiming to have a deeper knowledge of the maybe other systems or subsystems that they have less expertise in. But for many others, managers, those leading teams, it's equally important to be able to sort of converse and to lead teams, even if you're not the one building the system yourself, or to be able to work with external contractors or technical support in an informed way. And this will build your skills to be able to do that too.
Thank you, Professor Shaw, for making those distinctions here and what the program will and will not cover. And certainly as you think about advancing your education and what you're looking for next, that's one of those areas that you'll be exploring. How technical do I want to go? How deeply do I want to dive into some of these more technical components? And this course certainly, as Professor Shaw has highlighted here for us, allows you to communicate across channels of both technical and non-technical colleagues. And so certainly that's going to be a huge value add. And we'll also give you some insight if you'd like to dive more deeply into programming languages. That may very well be a great next step for you after this program concludes. So thank you, Armand, for the question here, and Professor Shaw for that excellent response and making those distinctions. So Armand, you're also asking, what hardware do you need? There's no additional cost here and no hardware that you'll need to purchase in advance. We've made it all very easy for you, and the entire learning system here is all within the same platform here. So there's no additional resources or books or hardware or anything like that you have to get in advance. We've made that all very convenient right there in the program. Rest assured, you'll have an entire week. We call it week 0 to orient with the program. So you'll have an entire week, Armand, to go on, take a look at what some of those tools and components are, make sure that you have your system set up and ready to go, as well as interact and network with your colleagues, your faculty, your course leaders. So you have an entire orientation week where you can reach out for support if you encounter any technical issues with the system that you do have, or any needs beyond the program there. So you have a full week there to do that. So another question here from Armand: how much of the course is software automation as compared to hardware automation? I'm going to pitch this one over to our professors. Professor Rodriguez, do you want to take this one for us?
Yeah, I can take this one. Thanks, Armand, for the question. So we aim for this course to focus on, if it makes sense, robotic automation, and in the context of that, we do need to speak about software, the software part of the solution, as well as the hardware part of the solution. But that doesn't mean that we do cover things that would classically fit into hard automation or designing sort of special purpose machines for very specific tasks, right? So we will talk about hardware in the context of mobile bases or different types of arms, or I don't know, drones or sensors. What are the subcomponents and the options that you have for building the hardware aspect of a robotic system, and how that ties with the more algorithmic part of programming that robotic system.
Can I follow this up, if you don't mind? Armand was asking about those different components, and also a question from Moisen: how do we get that hands-on experience that we talk about and bringing these concepts to life if there's no hardware used in the program? So could you, Professor Rodriguez, Professor Shaw, help to kind of color in the lines here? How are we really bringing to life these concepts without something tangible to hold on to?
Oh, okay. Yeah, no, that's a really, really great question. So what we do in this course is we ground much of what we're teaching with examples of real systems, both examples of robotic systems that, Alberto and I have each developed ourselves in our lab and deployed. Those that others have developed, we pull examples and case studies from systems in use in industry. We also bring in, as interviews, practitioners, founders of robotics companies and startups to sort of help make concrete, the various learning objectives of this course and their importance, and how they're how they can be grounded and be useful to you in your real world practice.
Professor Shaw, for providing that next layer there. Youngjun is asking, and this has been upvoted by another participant here, do you have target robotic systems which will be covered? Examples given: manipulator, mobile robot, drone, etc.
Yeah, I can take that one. We do not have one single targeted type of robotic system, and we do cover several examples. Arm manipulators are certainly covered. Mobile manipulators and bases are certainly covered, as well as other platforms like drones, for example, whenever sort of it's appropriate for the specific topic we're covering in that week, or in that particular activity in that week. So we do try to sort of cover a broad range of sort of opportunities, so to speak, or scenarios, and try to make the connection with the system aspects of those particular scenarios.
Certainly. Thank you, Professor Rodriguez. But I see Manhari's question. It was posted a few times, upvoted by a couple of participants here. After completing the course and during job searches, can you request references from program managers? And the answer to that is absolutely yes. A big part of what you'll be doing here in this program is networking across these various relationships. You'll be building a network here in the program. And if you were with us at the beginning, you heard me invite you to say hello there in the chat. So just so I can call out some of who we have with us here. In terms of the countries represented, we have Australia, England, Singapore, Florida, Malaysia, Minnesota, Mexico City, Indiana, Boston here with us on the line, London, Australia. So certainly, as you think about some of those relationships that you'll be building, you'll not only have a chance to build relationships with your peers, and they represent not only different geographies, but different industry areas, different job functions, professional roles, different levels of work experience. Some will be just starting out in their careers, other have more of those leadership focus or mid-career responsibilities, and still others will be executives really looking to communicate more fluidly across non-technical and technical teams. So many different peers to learn from. Your course leaders certainly at the helm of that day-to-day learning experience. They'll be on the discussion boards with you and your peers, helping to push your thinking and drive engagement throughout your time in the program. So you'll be building those relationships with them as well. Your program advisors who you're meeting with today, and hopefully in the coming days as you prepare to begin the program. All of these folks, as you're building relationships, are going to be great resources for you as you seek to build your references and build your reputation here towards job readiness. this. So certainly all of that is designed as a big attribute and a big takeaway from this program. It's one of the things that makes this program special. It's not a MOOC, a massive open online course that simply delivers information, but this is a highly specialized cohort model that allows you to learn in that hands-on way in real time and in an immersive fashion. So a lot to look forward to here in the program. I see another question here coming in from Ange. You said you're in construction. You don't have any coding knowledge, and certainly you don't need that as a prerequisite for this program. But it looks like you're brand new to technical topics and themes in general. You see the potential of this course in the construction industry. Is this going to be a beneficial course for you, or is it a long shot? I'm going to pitch that one over to our professors. What would you say? You guys designed this program. Is Ange a participant that you think would be a great candidate here for this program?
Yeah, so thank you so much for that question. I'm happy to start. Yeah, there's really exciting and emerging opportunity and increased use of robotics and automation in construction. It's a really sort of dynamic area right now for robotics. If that's an area you're looking to sort of work more in or liaise with, as technologies are increasingly introduced, I think there is an important opportunity to understand both the current state of the art, which is changing quickly, but also the limitations or the very particular cases that can make it really challenging to use some of these technologies that might look really successful in other industries. That construction does have a lot of opportunity, and there's also reasons it's very different than sort of a traditional production environment. And there can be positives to that and sort of challenges to that, depending on the particular technology, depending on the particular subsystem that's the critical link in making something successful for your application. And so if you're looking for a course that can bring you up to speed on the state of the art, then this is a good course for that.
Thank you, Professor Shaw. Another question, I just picked it up from the chat here, and it's about
the required technical background, both as it applies to coding or math, let's say. I just wanted to add one more thing there. In our thinking when we were developing this course, our idea is that we think that the system aspects of robotics are so important that they should be a course that is accessible and useful for both people that do have that background and for people that do not. And in the process of designing this course, we took that into consideration. And if you take this course, you will see that through it, there will be many opportunities where you can decide, if you feel like it, to go deeper into certain topics in the form of extended workbooks that go a bit deeper into the math, for example, of a specific algorithm, or into the pseudocode formulation of a particular algorithm. So we provide links, we provide references so that you can expand. All of these are sort of optional activities, but we try to provide all of those opportunities so that if you do want to, you can go into the depth of some of the more technical aspects, but trying to make sure that you still get the benefit of the entire course if you don't have that background. I just wanted to sort of clarify that point.
That's absolutely an important distinction to make as well. And then as we think about the depth of this program, another question here from about artificial intelligence and how it folds into the curriculum here. But Manu Hari is asking, will there be basic AI teaching incorporated into the course? So, again, as folks look at this program, the curriculum, and some additional learning opportunities outside of this program, to what degree did you think about artificial intelligence as a whole, and how was that incorporated here into the curriculum?
I'm happy to get us started again. So as I sort of alluded to as we were talking about the different modules of the course, artificial intelligence is a broad field, and there are many sub areas of artificial intelligence. Task planning, is one of those. robotics, in particular, the emphasis that we have in this course on intelligent robotics is a really exciting field of artificial intelligence, these are systems that need to be able to sense their environment, understand some aspect of the current state of themselves, the environment, the current state of the task, and to be able to make decisions. Interestingly, a better robotic system is online relatively quickly at multiple levels, that represent each of those modules we talked through. And be able to do that in a way that is in sync, that meets sort of the requirements if it's a walking robot that can sort of stay, dynamically stable, or if it's a UAV, stay within stable flight regimes, and obviously need to be supervised or controlled by a person, or interacted with by a person. In the case of the work that I do, collaborative robots, a person in working interdependently with that robot in a variety of different ways. So these are, many dimensions of, a really exciting field of artificial intelligence. But the themes of this course center around sort of intelligent, robotic systems, which is integrally linked to the modern day artificial intelligence.
Thank you, Professor Shaw. So we have reached the end of our questions here today, and I'd love if both of our professors here help with a final send-off here. But firstly, you can also use that email address listed there for you in the chat. That's mit@emeritus.org. Certainly just let us know by email. And then there's a third channel, and perhaps the easiest channel to getting connected with an advisor is to simply wait for copies of today's recording to arrive in your inbox. We're going to be following up within 24 to 48 hours to provide you with copies of the recording, as well as all of the slides that we've covered here today. You can reply all to that email and let us know you need an advisor, and we will set you up through email that way. So a lot of different ways to get plugged in. I'm going to go ahead and close out our time here together by inviting both of our professors for any final words of wisdom.
I guess start just by thanking everyone that joined and that is thinking of taking the course. I'll just say that both Julie and I, as in our sort of job as faculty in robotics, we're a specialist in our day-to-day activities, right? So we focus on specific aspects of robotics, but we do have an appreciation for robotic systems and for the importance of both the modularity and the compositionality of these systems, and trying to understand them as a whole. And even though becoming a specialist, it's important at some point. We when conceiving this course, we try to put together the course that we wish that we could have taken sort of when we were starting working in robotics, having some broad perspective into the different aspects of a robotic system and how sort of our own specialties sort of affect everything else, which is something that we've sort of been exposed and learning over time. And I guess sort of that's the perspective that we've taken into putting it together.
Yeah, absolutely. I echo everything Alberto just said. And I now actually use parts of this course in my residential teaching. Even is how excited we are about sort of the ways that we work together to put this course together. And maybe the thing that I would add to that is just the relevance of this course to really everybody, because we're at this really interesting, exciting age of increased use of robotics and automation, not just in these sort of production or specialized environments, but with autonomous vehicles on our roads, sidewalk delivery robots in offices and workplaces, and we also aim in this course to be able to discuss and support you in being able to consider and work through the sort of societal implications and the ways in which we make decisions about the design of these systems and the effect that can have, and the choices that we have, all of us in sort of building and designing these systems to achieve a positive future for for everybody involved. And so we're very excited about this course, and we're very excited for you to take it with us. So thanks so much.
Thank you, Professor Shaw, Professor Rodriguez, for being here with us. It's been an absolute honor learning from you both here about this program. Certainly an exciting opportunity. So never a better time to begin learning more about robotics and its implications on the work of today and in the future. So thank you all for being here. Thank you for your engagement, your participation. And with that, we're going to sign off here today with our heartfelt gratitude and a warm good morning, good afternoon, good evening, and good day to all of you. And we hope to see you soon in the program.